Okay, so here's objective 2.3a. So we're going to be solving equations today for x. Look at these equations, guys. But what I'm going to be teaching you today, I'll just refresh how to algebraically solve them. But what my task is today is to teach you to use your calculator to solve the equation by using what we call the intersect method. So we're going to solve linear equations, and we're going to do algebra versus intersect method. So intersect method's the new skill that we're practicing today. Essential question is, how do I use a calculator to solve an equation for x? All right, so the first thing I'd like you to do is take a moment to pause this video and go into Canvas to right here or right here for in today's resources and watch a video on how to use how to do the intersect method with your TI-84 if that's your calculator, or with Desmos, and then take those notes. They're short videos, like a minute or two, and put them right here. Just take notes on those instructions and put them right there in your note page. And then when you're done, you're going to come back to this video and finish your notes. Okay, so I'm assuming that you paused this video, and you went and watched one of those two videos. Now what we're going to do is we're going to solve these two examples here. Okay, so for example 1, this is going to have one solution. This is what we call a consistent equation, because there is one number we can plug in to the equation to make it true. There is one solution. So algebraically, if I were solving this equation, a couple of things I could do. I could just go ahead and solve it for x, or I could clear the fraction. I like to clear the fraction, so to do that, what I do is I find the least common denominator for 5, which is 20, and I just multiply 20 on each side of the equation. Now I'm just going to distribute 20 to each term, because if I am going to change an equation and rewrite it, I do have to change all the numbers in the equation the same way. I have to treat the left side the same as the right. And since I'm multiplying, I have to multiply everything by the same value. So 4 cancels the 20, because 4 goes into 25 times. And then 5 cancels the 20 because 5 goes into 24 times. So we have 15x minus 20 equals 28. So I like to clear the fraction because I don't like to do math with fractions. It's just a preference. We'll add 20. So we get 15x equals 48. Divide by 15. We get x equals, simplify. They both have a 3 in common. 16/5. And so that's our solution. This is an indicator that this is a consistent equation because it only has one solution. We call it consistent. So that's just a review of how to clear the fraction to solve an equation. That's Algebra 1. Let's use pre-calculus. Now the intersect method, if you watch the video, what you do is you take the left side of the equation and you set it equal to y. And if you're using your TI-84, you're going to put it in your y sub 1. And then you're going to take your right side of your equation and also set it equal to y. You'll put that in your y sub 2. And then you're going to find their intersection. So with your TI-84, you would go in second, trace, number 5, and you'd go through the steps to find the intersection. With Desmos, I've already got those entered here, and so for purposes, time purposes, oh no, I shut it down. That's okay, I'll just type it in real quick. Y equals, oh, I forgot what the equation is here. I have it right here. 3/4 x minus 1. So there's an equation, and the other side was y equals 7/5. All right. And so what I'm looking for is, where do those intersect? So all you have to do on Desmos is mouse over the intersection and get that point right there. So the point for the intersection is 3.21.4. Well, we're interested in, if we plug in a 3.2, we get out a 1.4. We're interested in the x value 3.2. Now, how do we convert that to a fraction? In Desmos, if you type in 3.2, if it'll convert to a fraction in Desmos, you'll see what happened on the number 3 when I put in the point. So see what just disappeared when I took the 2 away. Watch what happens under the number 3 equation when I add the 2. It pops up with that little symbol right there. And if you mouse that, if you click on that, it'll convert it to a fraction. That's a fraction symbol right there. So that's x equals 16/5. So we would get an intersection at 3.2, 1.4, and that was our interest. What is x? So we made the calculator solve for x, and then if we were to convert that to 16/5, it actually is 16/5. My preference when you're typing these answers in, if I give you a problem that has fractions in it, you give me an answer that is a fraction, not a decimal. Okay? All right, so there's one example. Let's look at example 2. All right, now the only reason I even have there's 2 reasons I have this here. And here's the first reason. When I go to solve this algebraically, here's what I don't want to see. You doing 8 minus 3 first and making that 5. That's not how you solve equations. Distribute and get rid of parentheses before you add or subtract anything. So 10 minus 6x equals 8 minus 3x minus 6. Okay, combining like terms, 2 minus 3x equals 10 minus 6x. You guys know how to solve that. I'm going to stop talking you through it and just solve it. Okay, so I got x equals 8/3. Now, just a little side note here. Again, this is a consistent equation. Consistent equation. Because it has one solution. Okay? But here's the problem with thirds. If I see a third as a decimal, that's 0.333 forever repeating, right? If I see 2/3 as a decimal, 0.666666 repeating, right? And in a calculator, you'll get 0.666666, and then at some point it'll round to 7 because it can't just keep writing sixes forever. Okay? So when we have 3 in the denominator, our decimal, which our calculator is going to give us a decimal answer here, it doesn't have a choice. We have to remember our rule of thirds. Okay? So intersect method just says, all right, that's algebra. We already know how to do that. So let's take the left side of the equation and type it in. Y equals 2 times 5 minus 3x. Also, please don't simplify that before turning it in. Don't do this and plug in 10 minus 6x. Don't do that. Just type it in exactly how it is. Right side, type in y equals 8 minus 3 times x plus 2. Exactly how it is. Okay, so we'll go to Desmos and let's see what we get. So I'll just go ahead and turn those 2 off and enter y equals 2 times 5 minus 3x. Sorry, I have to go back and look at my notes. And so there's that line there. And then the second one, y equals 8 minus 3 times quantity x plus 2. And there you have your 2 lines. Different slopes here. And I'm zooming in here, and I'm just going to tap on the intersection. And you can see your intersection, 2.6666, 2.6667, negative 6. But watch, if I go and put 2.6, that is going to give me a fraction, because that's 2 6/10. But if I keep going, and then it had a 7, notice what happens. If I were to convert that to a decimal, it wouldn't work. Let me take this. It does keep going, but if I were to convert this value to a decimal, it doesn't give me a third. It gives me 100. Yeah, that's not what I'm looking for there. So remember, when you get answers like 0.6667, that's 2/3. So it's 2 2/3. So again, our point is 2.6667, negative 6, and that is a rounded solution. So we get 2.6667, negative 6. Our concern is here. So how do we verify that that's that? Well, sometimes it's easier to turn that into that, but this is my preference for homework. But if I want to turn 8/3 into 2.6667, what I do is just do 3 goes into 8. Add some decimals and divide. 3 goes into 8 twice. Subtract, bring down the 0. 3 goes into 20 6 times. 18, subtract 20. You can see it's just going to continue to go over and over and over again. So 8 divided by 3 is 2 2/3, or 2.666. Another way you could look at this, because you saw this and you recognized it was a thirds, you could write it as 2 2/3. And then you could convert it to a fraction by going, this is a mixed number, 3 times 2 plus 2, 6 plus 2 is 8 thirds. And so they are essentially the same thing. Okay, so those are your consistent equations. So that happens when you get two lines that intersect. But that's not the only way that lines can interact on a graph. You can also have two lines be parallel to each other. And if they don't intersect, then they don't have a consistent solution. Also, so you can have intersecting lines, you can have parallel lines, or you could have one line graph right over the top of the other and then end up being the same line. So those are our conditions that we can create. So let's talk about our special cases. The identity equation. So algebraically, that's why I put a big O-A over here. Algebraically, the definition of the identity equation, when you go to solve it, the x's cancel. And the leftover equation will be true. Okay, so like for example, the x's cancel and you get 5 equals 5, and on the left is identical to the right. And whenever you see an equation where the left is identical to the right, that's an identity equation, identical. Okay, so that means that they share all of the x's. All of the x's are the solution, all of them. So all real numbers. Algebraically, that's what's going to happen. If your x's cancel and the equation is true, then it's all real numbers. Using the intercept method, what's going to happen is you're going to see one line, just one. One's going to graph right on top of the other. So in that case, we get what's called coinciding lines. They're basically the same lines. They share all of their points. Okay, coincidental. It's the same thing, right? They overlap at every point. They have the same line. They have the same slope. They have the same y-intercept. So all real numbers, if you get a graph of a line and another line that graphs right on top of it, your solution is all real numbers. Okay, so that's overlapping lines. Then the last type of equation is what we call the inconsistent equation. So algebraically, if you solve it, the x's cancel and the equation is false. Therefore, they don't have a solution. So you'll get an answer like this, 7 equals 10. That's false, and there's no x's in it. When that's the case, no solution. Intercept method, what happens is you'll graph parallel lines. They don't intersect, meaning they don't share an x. No solution. Same slope, different y-intercept. Okay, so let's take a look at these two examples. Which one is inconsistent and which one is identical, right? Look at this equation here. Negative 24x plus 7, negative 24x plus 17. Those are different, right? We'll go ahead and solve it. Negative 24x plus 7 equals 17 minus 24x. We'll add 24x to both sides. Cancel, cancel. You get 7 equals 17. This is false. The x is canceled, not a true statement. X is an empty set. There is no solution. If you were to graph them, you would make the left side y equals negative 24x plus 7. The right side, y equals 17 minus 24x. And for time permitting, I'm not going to have time to actually go and plug those in. But believe me when I tell you that this is what's going to happen. You're going to get parallel lines. When you graph parallel lines, no solution. It is an inconsistent equation. Okay? So in your homework today, if that happens, no solution. Last one here. This is definitely the identity, right? Because look at the left and the right. They actually are identical. I could rewrite this to say negative 1/3 x plus 3 equals negative 1/3 x plus 3. The left and right are identical. This is an identity equation. We'll go ahead and solve it algebraically. I'll add 1/3 x to both sides. Cancel, cancel. I'm left with 3 equals 3. I also could subtract 3 from both sides, and then I'd be left with 0 equals 0. Either way, still true. Okay? So, this means x equals all real numbers. Okay? So if I were to plug this into the calculator, I would make the left side 3 minus y equals, sorry.
Along with wearing your mask. Please follow the posted rules, follow all arrows for directional travel. Remember to stay 6 feet apart and social distance. Wash your hands and use hand sanitizer often. Remember, it's always a great day to be a hawk.
Okay, sorry about that. So last thing here is I would make each side equal y, and what would happen, and you can see that they're the same equation, that you would graph one, and then on top of that, you're only going to see one graph, and you would graph again, and you're going to see that they graph the same line. And so when that is the case, the answer is all reals, because they are coinciding lines. So there you go. That's how you use the calculator to solve a linear equation for x. See you later.